Today we are going to do another question, which is the resultant the resultant of two forces 3p and 2p is r. If the first force if the first force double doubled, and then the the resultant resultant also doubled doubled, um the angle between the angle between the two forces is, so the options that we have is 60 degrees, 120 degrees, C there is 30 degrees, and option D, which is 135 degrees. So since we are given 3p and 2p and r, I would have to assume that they are the magnitudes of the forces, right? um, since there is no arrow hat symbol, so I would say this is, um, I think this is magnitudes. So we'll just suppose that and move on. So supposing that they are magnitudes, first of all, we know that when we are using the resultant as r, we have square root. So instead of writing square root, I will just square this, right? So square root will go off. So r squared must equal a squared. So a was 3p squared plus b squared. B will be 2p squared, right? It's 2p, right? Plus 2a b cos theta. So theta is the thing that we have to find. So let's just do some quick math. So r squared is going to be r squared, 3 squared is going to be 9, p squared is going to be p squared, plus q squared is going to be 4, p is going to be p squared is going to be p squared, 2 times 3 times 2, 2 times 3 is 6, 6 times 2 is going to be 12, so 12p cos theta. So this, okay, once more we can do this. So 9 squared plus 9 plus 14 is 13p squared plus 12p cos theta. So let's call this 1. Now in the next page we are going to talk about what happens in the second part. So we have that the first force doubled and the resultant also doubled. So first force, which is 3p, when 3p was changed to 2p, right? Sorry, not double, meaning like 2 times 3p, so 2 times 3p, then the resultant r also changed to 2 times r. So this is the thing that we need to do. So again, using the formula, which is r squared, so r in case here is 2r squared, is gonna be a squared. So a is 6p squared, since 2 times 3 is 6, so 6p squared plus b squared, which is 2p squared plus 2ab cos theta. So let's do some. 2 squared is going to be 4, so 4r squared, 6 squared is going to be 36, and p squared is going to be p squared, 2 squared is going to be 4, and p squared is going to be p squared. 2 times 6 is going to be 12, so 12 times 2 is going to be 24, right? Let's do quick math. So 2 times 2, 4, 4, 6 are 12. So this is p squared cos theta. Again, you can add them up. So 4r squared is gonna give me 40 p squared plus 24 p squared cos theta. And I think everything can be divided by 4. So dividing the right hand side and the left hand side by 4, you get r squared must be equal to 10p squared plus 24 by 4. 24 divided by 4 is 6. So 6p squared cos theta. So this will be our equation number 2. And I think I missed a square somewhere over here. So there is a square missing, there is a square missing. So we have this. So let's subtract 1 and 2. So subtract 1 and 2. So if you subtract 1 and 2, let's see what happens. The r square cancelled out, so it's going to be 13p squared minus 10p squared, which is 3p squared. So 3p squared, so 0 equals 3p squared, and we have 12p squared cos theta minus 6p squared cos theta, so you will have 6 left, so plus 6p squared cos theta. Let me check it once more. Yep, right. 13 minus 10 and 12 minus 6. So we have this. So moving that over there, we have minus 3p squared. So subtracting both sides by minus 3p squared, you will get 6p squared cos theta. Dividing both sides by p squared and 6, you will get cos theta to be minus 1/2. And if you remember the cos 120. So let me put it in my calculator. Cos 120 is 1/2. So cos 120 degrees is 1/2, which means theta and the angle that we needed is 120 degrees. So the answer is obviously going to be 120 degrees. Pretty interesting problem, I would say so myself. Very very easy, but very complex as well. So if you don't know what to do, you will be very stuck on this problem. I think this problem is finished, and I think you understood what I was trying to do. So this was it for today's video. On the next video, we are gonna do another question. So till then, bye bye.